So we are in physics. Subject code is 3110018, and we are in first unit, electronic materials. The expected course outcome for this unit is that the student will gain knowledge of basic theoretical and mathematical concept of electronic materials. Here is the outline of your unit: free electron theory, density of states, energy band diagrams, Crony-Penny model, EK diagram, direct indirect band gaps, types of electronic material, metal, semiconductor, insulator, density of state, occupation probability, Fermi level, effective mass, phonons. Free electron theory, two free electron theories we already have seen: classical and quantum free electron theory. Density of states we already have derived. Okay, and Crony-Penny model is the next free electron theory model, which I'll take in extra classes because I'll need 2 hours continuously for that. And based on that, we will classify the material in terms of bands, energy bands, right? And Crony-Penny model is the theory which gives rise to EK diagram and its significance. So that will come next once we finish up with Crony-Penny model. During this topic, this topics, you will be clear with the difference between metal, semiconductor, and insulator, because we'll be discussing band gap, allowed bands, and so these two topics will be discussed along with Fermi level. We already have discussed earlier: Fermi energy, Fermi level, formula for Fermi energy at 0 Kelvin and at temperature higher than 0 Kelvin. Today we'll be taking up these two topics. Okay, so next in extra class I'll take Crony-Penny model, and then consequently these topics will also be covered. Let us see how we have approached this unit so far. So we started with classical free electron theory. That is the first step towards free electron theory. Not very much relevant with the explanations and theories and concepts which we have today, but it is just for you to know that how all this exploration started. In that also we started with very basic 12th standard topics. We saw postulate, we saw what classical free electron theory gave us, some derivations and formula based on classical free electron theory. Then we had merits and demerits of classical free electron theory. Okay, because of the demerits of classical free electron theory, another theory was very much needed, and that was that need was satisfied by quantum free electron theory. Though it could improve a lot on classical free electron theory, it could not satisfy everything, it could not explain everything. And so there are so many merits and demerits of quantum free electron theory also, which we had seen, and today also we'll revise. To understand next free electron theory model, we need certain things, like we need to know different types of statistic, we need to know Schrodinger wave equation. So we had seen 3 types of statistics, then a few definition, then Fermi-Dirac distribution function also we discussed, based on which we could understand density of states. And the last 7th topic, Schrodinger equation and its solution. Though it is not directly mentioned in your syllabus, but it is very much needed to understand Crony-Penny model. So that is what we had covered last time. Topic today should have been Crony-Penny model, but as I said, it's better if we discuss it at a stretch in 2 hours session. So I'm skipping it, and we are taking up the last topic, which is comparatively smaller. These are the possible questions from the topics which we have covered so far. Let us have a quick look at the topics which we have done. In one session, we'll be taking up numericals. To solve numericals, you will need to know all this formula. So it's better if you keep a separate list of all the formula. This is drift velocity, then vector form of Ohm's law, J is equal to sigma E, then postulates, 10 postulates. Formula for electrical conductivity. Now here I would like to add one thing, that while discussing electrical conductivity or thermal conductivity, we considered all the physical aspects, like where are the ions or what electrons are doing. But there is one more thing which is affecting electrical and thermal conductivity, which is vibrations of the ions. And how ions vibrate, that also affects these two, sigma and K. So that quantity is called phonon, which we will see today. This is thermal conductivity. Again, keep one thing in mind, this formula, all this formula are derived based on classical free electron theory, which has its own shortcomings. So in real time, if we try to apply this formula and try to find out sigma or K, the actual values and the theoretical values may not be same. And that thing we already had realized when we calculated Lorentz number. The theoretical value and experimental value both were not in very much match. Merits of classical free electron theory, demerits, so many demerits. And so Sommerfeld proposed quantum free electron theory based on some postulates. It has its own merits and demerits. Then three types of distributions, distribution functions: Maxwell-Boltzmann, Bose-Einstein, and Fermi-Dirac. I intend to show you derivation of this formula also, but as again it's going into too much detail for this unit, so I'll try to keep it in extra class. Two definitions, short definitions, easy one. But again, as I said, this formula will help you in numerical, so don't neglect such formula. Then we had Fermi-Dirac distribution function. It is basically a probability function. It gives you probability of finding electron in the given energy level at given temperature. This is how Fermi distribution function, which is also called Fermi factor, varies with energy. This graph is for 0 Kelvin, when temperature is 0 Kelvin. But if you vary the temperature, if you increase the temperature, nature of graph changes slightly. A very important topic, density of states. We'll need this expression when again we see the charge distribution in conductor and insulator. We might need this formula today. Energy is h cut square k square by 2m. This is the formula which shows that for 3 dimension G is proportional to root E. Then based on this formula, we saw how to find out number density of charge carrier. We need to multiply density of states and the probability function, and then we can graphically and mathematically find out number density of charge carrier at different energy level. And if we see density of states for 2D, 1D or 0D, the nature of the function is not same. See, this is how G depends on energy for 2D, then 1D, and then 0D, that is quantum dot. Lastly, in last lecture, we did discuss what is Schrodinger equation, which is something inevitable if you are pursuing any course of modern physics, or even if you go into too much detail of any electronic material courses. So you will often encounter this term Schrodinger equation, and so I felt that you should be knowing basics of Schrodinger equation, what is called Schrodinger equation, and how to arrive at it. So we had derived Schrodinger wave equation. This is the Schrodinger wave equation. Of course, there is another form. There are so many different forms of Schrodinger wave equation. The most popular one is this one. Let me show you. If I rearrange the terms, this fifth equation can be written like this. So is this okay? I'll just rearrange the terms, and now if I multiply all the terms with 2m by h cut square, what we get is 2m by h cut square e minus u into psi. This is more popular form of Schrodinger equation, but fifth one is also Schrodinger wave equation only. So this is the Schrodinger wave equation, which demands that any electron should have a wave corresponding to it, and that wave is psi. So afterwards we had tried to find out solution for this Schrodinger wave equation, and this is what we got ultimately, that psi is root 2 by L sine kx. Okay, and then if you solve this, you will realize that kx should be equal to n pi, and then you can find out different values of k. So that is what we have done so far. Now let us come to today's task. Today we are targeting two topics: effective mass of an electron and phonons. Okay, so let us start with effective mass. Now, what do you mean by effective mass? Can you guess anything from its name? તમને નામ ઉપરથી કાંઈ અંદાજ આવે છે કે ઇફેક્ટિવ માસ કેવું હોવું જોઈએ? Any guess? Anyone, any guess?
Sir, કોનું effective mass?
Very good question. કોનું effective mass? Whose effective mass we are talking about? We are talking about effective mass of electron. Do you know what is the mass of electron? Mass of electron, I think, is 9.1 into 10 raised to minus 31. You can take it as 9 into 10 raised to minus 31 kg. So far we never had term like effective mass. Whenever we want mass of electron, we take 9 into 10 raised to minus 31 and we go ahead with that. Now we are talking about effective mass of an electron. Now what do you mean by effective mass? What do you mean by effective mass? Guess. કંઈક વિચાર કરો, તમારા મગજમાં જે જવાબ આવે એ જવાબ આપો. Give it try at least.
Proper electron નું જ mass એમ.
તો આ શું છે? 9 into 10 raised to minus 31 શું છે? Electron નું જ mass છે, isn't it? Okay, let me remind you, you must have studied in 11th standard.
સર કોઈ પ્રક્રિયા દરમિયાન જેનું પરફેક્ટ માપ હોય તે.
Okay, consider there is a person standing in lift. The mass of the person is 60 kg, and so weight of the person is 60 into g. Weight એટલે mg થાય. બરાબર, તો 600 ન્યૂટન થાય. Now what if the lift starts going up? Suppose the person is standing on weighing scale. એ ભાઈ છે એ એક કાંટા ઉપર ઊભા છે, બરાબર, અને લિફ્ટ ઓચિંતાની ઉપર જવાનું સ્ટાર્ટ કરે. Would the weighing scale still show 600 Newton or the reading will differ?
Reading will differ.
Okay. શું થાય?
Reading will differ.
ડિટેલમાં મને આન્સર આપો. શું થાય?
સર જેમ જેમ ઉપર જશે તેમ તેમ વધતું જશે રીડિંગ.
વેરી ગુડ. અને જો લિફ્ટ નીચે આવે તો? What if the lift is coming down?
ઘટાડો થશે.
Very good. And what is the explanation for this phenomena? આવું શું કામ થાય? Okay, you might have forgotten the reason. Reason is, we say that F is equal to ma, Newton's second law. Now, this is true for non-inertial frame of reference. And when you have inertial frame of reference, you will need to consider pseudo force also. આભાસી બળ એવું કંઈક તમારે આવ્યું હશે. So
Yes.
when lift is going up, while going up, the pseudo force is downward. Okay, so it is as if the person is being pulled down. જ્યારે લિફ્ટ ઉપર જતી હોય ત્યારે આભાસી બળ નીચે લાગે, તો માણસને કોઈ નીચેથી ખેંચતું હોય ને એવો આભાસ થાય. અને એટલા માટે mg અને fp બેનું એડિશન થાય, right? So mg plus ma is pseudo acceleration and the mass of the person, and then the person may be weighing more. તો પછી કદાચ એવું બને 600 ન્યૂટન ની બદલે 1000 ન્યૂટન થાય. ઓકે, 1000 ન્યૂટન ને mg માં તમે સબસ્ટિટ્યુટ કરો અને m કેલ્ક્યુલેટ કરો તો m આવશે 100 kg. It means that the person would behave as if he is having 100 kg mass. Similarly, if the rope suddenly cuts down, ધારો કે આ લિફ્ટનું જે દોરડું છે એ ઓચિંતાનું તૂટી જાય તો સ્કેલનું રીડિંગ કેટલું આવે?
0.
0 આવે, because at that time the pseudo force will be upward while coming down. Pseudo force is upward, mg is downward, and so effective force is mg minus pseudo force. So this m will be less, and at that time it is possible that the person is having 0 kg. Okay, so it means that we may say that mass of the person is 60 kg, but not necessary that the person behaves as if he is 60 kg always. કોઈ વાર એવું બને કે એનું જે દળ છે એ 60 કિલો કરતાં વધારે હોય એવું લાગે, કોઈ વાર ઓછું હોય એવું લાગે. It depends on the situation of the person. This is very true with electron also. Electron માટે તે આવું બને ખરું. Let us see why this should be true for electron. See, when you talk about free electron, actually it is not free. આપણે જેને free electron કહીએ ને એ સાવ તો free નથી જ. Because it is moving between the space available in the solid between the ions. આ જે બધા ions છે, ધન ion છે, એની વચ્ચેની જે જગ્યા છે એમાં આપણો ઇલેક્ટ્રોન આંટા મારે છે. ઓકે, so when I say that I have applied electric field, ધારો કે આપણે બહારથી બેટરી કનેક્ટ કરીએ અને એક ઇલેક્ટ્રોન છે એની ઉપર આપણે ફોર્સ લગાડીએ. Suppose there is electron and it starts moving like this. So we say that the force, external force is ma, and this external force is QE, which is equal to ma. What is this m? This m is mass of electron. And based on this, we had derived mobility and conductivity and current density and all those things we had derived based on this logic, which is not entirely true. What actually happens? Actually, electron is not influenced only by F external. એની ઉપર આ જે આયન્સ છે, આયન છે એ તો ઇલેક્ટ્રોનને એટ્રેક્ટ કરે કે ન કરે? These are positive ions. So when electron passes by some ion, this ion will definitely attract it. It means that this electron is experiencing two forces. What is F external? F external એટલે શું? What is F external? It is the force due to electric field which we have applied from outside. બહારથી જે આપણે બેટરી કનેક્ટ કરીએ ને, એ બેટરી નું જે ઇલેક્ટ્રિક ફિલ્ડ છે, વિદ્યુત ક્ષેત્ર છે, એ ઇલેક્ટ્રોન ઉપર બળ લગાડે. That is F external. What is F internal? F internal એટલે કયું બળ? F internal is the force again of electric field. એ તે વિદ્યુત ક્ષેત્રનું જ બળ છે, પણ એ વિદ્યુત ક્ષેત્ર કયું? જે ધન આયન છે એનું જે ઇલેક્ટ્રિક ફિલ્ડ છે એનું બળ. So if the positive ions are oscillating, the electron will experience variable internal force. બહારનું બળ તો છે જ તે, પાછું અંદરના જે ધન આયન છે એ એક બળ લગાડે. And hence the mass of electron cannot be determined by this formula. Just like this case, when the person, ધારો કે તમે ચકડોળમાં બેઠા હો ને, તો ચકડોળ જ્યારે ઉપર જાય ત્યારે અને નીચે આવે ત્યારે તમને અલગ અલગ ફિલિંગ આવે. સપોઝ if you are in merry-go-round and if merry-go-round is going like this, when you are at point A and when you are at point B, the feeling which you get is not same. તમને ખબર છે A point ઉપર હો ત્યારે કેવું લાગે? How would you feel when you are at point A? You will feel heaviness. You will feel as if you are heavier. And what if you are at point B? At A point you are going up, pseudo force is acting down, so you will feel heaviness, too much heaviness. But when you are at point B, you are coming down suddenly, and so you will feel lightweightness. તમને એવું લાગે કે તમારું વજન ઓછું થઈ ગયું છે. It means even though you are the same, depending on your situation, your mass is varying. This is true even for electron also. For electron, this F internal is not constant. ઘન પદાર્થના અલગ અલગ ભાગમાં F internal નું મૂલ્ય અલગ અલગ હોય અને એટલા માટે ઇલેક્ટ્રોનનું દળ પણ બદલાતું રહે. Okay, so that mass.
સર
બોલો
સર, પણ ફિઝિક્સમાં તો એવું હોય કે દળ અચળ હોય.
એવું હોય એવું તમને કેવી રીતે ખબર પડે કે ફિઝિક્સમાં એવું હોય?
મતલબ સર એવું સ્ટડી મતલબ કર્યું હોય ત્યારે.
હા, આપણે છે ને મોટાભાગના આપણે રેફરન્સ ક્લાસિકલ ફિઝિક્સમાંથી જ આવે, એટલે જે ન્યૂટોનિયન ફિઝિક્સ કહેવાય ને એમાં આપણે દર વખતે દળ અચળ લેતા હોઈએ. કદાચ તમારે 11th સ્ટેન્ડર્ડમાં જૂના સિલેબસમાં એક વેરિયેબલ માસની થિયરી હતી કે રોકેટ ઉપર જતું હોય ને તો એનો પ્રવેગ કેવી રીતે શોધવો, તો એમાં દળ અચળ નથી રહેતું. બરાબર? ધારો કે કોલસાવાળી ટ્રેન હોય તો જેમ જેમ તમે કોલસો એન્જિનમાં નાખો, એન્જિન હાલે ને ટ્રેન આગળ જતી જાય, એમાં કોલસો ઓછો થતો જાય તો ટ્રેનનું દળ બદલાય કે નહીં?
યસ સર.
બરાબર? હવે અહીંયા એ લોજિક લાગુ નથી પડતું. Here the reason is entirely different, but my point is it is not necessary that mass is always constant. એ એનાલોજી અહીંયા એટલા માટે લાગુ નથી પડતી કે અહીંયા જે ઇલેક્ટ્રોનનું મેટર છે એ ચેન્જ નથી થતું, પણ ઇલેક્ટ્રોનની ઉર્જા બદલાય છે અને ઉર્જા બદલાય એનો સંબંધ દળ સાથે છે. ઓકે, સી E is, what is E? H cut square k square by 2m. Now if you take m as subject of formula here, it is h cut square by k square into E. E is not constant. Energy છે એ અલગ અલગ ભાગમાં અલગ અલગ હોય. Okay, k you can always vary. So if you take EK diagram, જે આપણે આગળનો ટોપિક છે, તો EK diagram આવો આવે. E versus K diagram if you take, it is like this. So at different K, if you take energy, it is different, and then if you use this formula, you will get different answer for mass. એટલે જે બહુ માઇક્રોસ્કોપિક પાર્ટિકલ છે, ટાઇની પાર્ટિકલ છે, એની માટે ન્યૂટનનું જે ફિઝિક્સ છે એના કન્સેપ્ટ છે એ 100% એપ્લિકેબલ નથી. Getting me?
Yes, sir. Yes,
So
sir.
mass is not constant, right? Now, how do we know how much is the mass? So let us see the derivation for formula of effective mass. When an electron is in periodic potential, is accelerated by electric field or magnetic field, the mass of electron varies according to its velocity. What does it mean? So when lift is coming down, you feel lightweight, but if lift is coming down fast, you might feel zero weight. તો જેમ જેમ અલગ અલગ સ્પીડ હોય એમ એમ તમને દળમાં વધારે કે ઓછો ફેરફાર લાગે. That is true for electron also. So depending on electron speed, its mass varies when it is subjected to external electric field or magnetic field. બાહ્ય બળ લાગે ત્યારે ઇલેક્ટ્રોનનું દળ બદલાય. કેટલું બદલાશે ઇલેક્ટ્રોનની વેલોસિટી નક્કી કરે, which is in turn actually depending on temperature. Thus, the mass of an electron is function of its velocity and consequently depends on its energy. એટલે ઇલેક્ટ્રોનનું જે દળ છે એ એની ઉર્જા ઉપર આધારિત છે. And such variable mass is called effective mass, denoted by m star. The mass of electron which depends on velocity and energy is called effective mass, and it is not denoted by m, it is denoted by m star. If force acting on electron is F, then according to Newton's second law, F is equal to ma. But as I said, use this wisely. આ જે ફોર્મ્યુલા છે એનો તમે ઉપયોગ કરો તો થોડુંક ધ્યાન રાખો કે તમે F કયા F ની વાત કરો, કયા M ની વાત કરો છો, થોડુંક ધ્યાન રાખીને યુઝ કરવાની આ ફોર્મ્યુલા. So can I say acceleration is F by m0? What is A? What is A here? A શું છે અહીંયા? Anyone?
પ્રવેગ.
Praveg. A is acceleration. It is acceleration of the electron. Electron નો પ્રવેગ છે. Now, what about the force experienced by electron due to ionic motion? આમાં જે first equation માં F છે એ F એટલે કયો બળ? Which F you are talking about? So as I said earlier, if you talk only about electric field due to battery, બહારથી જે બેટરી લગાડી એનું electric field જ તે ખાલી લ્યો તો proper answer નહીં મળે. If you then calculate energy or velocity, you will not get proper answer because electron is influenced by other forces also. Electron ઉપર હજી એક બળ લાગે છે જે અંદરના ઇલેક્ટ્રિક ફિલ્ડનું છે, અંદરના વિદ્યુત ક્ષેત્રનું છે. That is called F internal. અને આ ક્યાંથી આવ્યું? Who is the source of internal force? આંતરિક બળનો સોર્સ કોણ છે?
Positive ion.
Yes.
અંદરના પોઝિટિવ આયન.
જે પોઝિટિવ આયન ઓસિલેટ કરે છે, વાઇબ્રેટ કરે છે, એને લીધે એનું બળ ઇલેક્ટ્રોન ઉપર લાગે છે. I want you to write down this answer because after this lecture you have to submit this. તો આ જવાબ તમારે મારી સાથે સાથે લખતા જવાનો છે. Write down this answer. As soon as this lecture is over, you will submit this answer. Raise your hand when you are done. જયદીપ કઈ કીધું?
એટલું જ લખવાનું છે કે આ સ્ક્રીન ઉપર દેખાય?
સ્ક્રીન ઉપર છે ને એટલું લખી નાખો, ઉપર ક્વેશ્ચનની જગ્યા રાખજો. ક્વેશ્ચન લેક્ચર પૂરું થાય ને એટલે હું દેખાડું ને સૌથી ઉપર ક્વેશ્ચન લખી નાખજો.
ઓકે સર.
Please raise your hand as you are done. લખાઈ જાય એટલે hand raise કરજો.
બાકી છે થોડું.
It's taking too long. I'll have to finish this topic, so I'm going further. You may take screenshot. So now the resultant force on the electron of mass m0 can be given as external force plus internal force. You may write down simultaneously. And now if I take F internal on the other side, I can say that F external is M0 plus F internal. Okay, and here if I write, it may be plus or minus. So M0 plus or minus M A. This is effective mass, which can be written as M star. M0 is called rest mass. Mass when electron is at rest. Mass when electron is not acted upon by any force. જ્યારે electron ઉપર કોઈ પણ બાહ્ય બળ ન લાગતું હોય ત્યારે જે બળ હોય, ત્યારે જેનું દળ હોય એને rest mass કહેવાય, which is M0. So F external only if you consider, જો આંતરિક બળ ન ગણો તો જે દળ છે એ ઇફેક્ટિવ માસ કહેવાય M star. Here M star 0 is known as effective mass. Now according to quantum theory, any particle can be represented by waves. તો કોઈ પણ કણ છે એને સામે એનું એક તરંગ સ્વરૂપ હોય અને એના વેગને ગ્રુપ વેલોસિટી અથવા વેવ પેકેટની વેલોસિટી vg કહેવાય. So we can say vg is d omega by dk. From where to get this d omega by dk? So we know that lambda v can be given as lambda into f, that is lambda by 2 pi into 2 pi f. I can always write this as, and that is 1 by k into omega, that is d omega by dk. But when the particle is moving, you don't have single wave, you have wave packet, and hence it is d omega by dk. So what is Vg? It is velocity of wave packet, which is representing electron, and omega is angular frequency, k is the wave vector, 2 pi by lambda. So why do we need this velocity? Because if I have velocity, I can find out acceleration. So if you take differentiation of this, you will get acceleration, and there is one more relation. We know that energy is h cut omega. So if you take dE by dk, you will get h cut d omega by dk. Okay, so make d omega by dk subject of formula. You will get this. Write down in 2-3 minutes. થોડુંક ઝડપથી એટલું લખી નાખો. અગાઉનું બાકી રહ્યું હોય તો એની થોડીક જગ્યા મૂકી દો, આટલું લખી નાખો. Okay, I'm changing screen. If anything is left, you can take screenshot and write it later. So we have got Vg, and velocity, if you differentiate, you will get acceleration. That acceleration we can substitute in second equation and find out effective mass. That is the logic. So acceleration is dvg by dt, and Vg is substituted here. So this is what we get. Instead of this d by dt, you can take dk by dt, d by dk and dk by dt. So you can always take d by dt as d by dk and dk by dt, because we know differentiation of energy with respect to k, and hence we prefer to do this. Moreover, there is one more advantage of writing this way. Say, if you take force and if you differentiate, you will get force in terms of dk by dt. So this part gives me d2e by dk square, that is d2e by dk square. And now if I somehow can get h cut dk by dt, this is external force. Okay, so what we do is we multiply and divide with h cut. See, I have multiplied and divided with h cut, so I have got h cut square, and then this part is external force. So now my equation is like a 1 by h cut square d2e by dt dk square and f external. Okay, so if I write this as f external, A 1 upon h cut square d2e by dk square, and then if I compare it with F is equal to ma, we realize that this is the mass. This term is the mass, and it is called effective mass of the electron. Do one thing, write down this derivation in your book. Write down the whole derivation in your book. You will have 15 minutes after completion of this lecture for submission. So make it fast. Okay, I hope you are done. Take screenshot otherwise. So this last one is called effective mass of the electron, and this is what you are supposed to submit before 1 o'clock today. Let us see now the next topic of phonon. You may keep one bracket here just to ensure that you are not confused in this step. Next is phonon. Now, what do you mean by phonon? Phonon is very similar to photon, and the way photon is considered as particle of light, ખરેખર તો light છે electromagnetic waves, બરાબર ને? But then we realized that light has particle form also, and the particle form is called photon. Very similar, if you consider sound wave, for sound wave also we can have corresponding particle, and that particle is called phonon. So when ions oscillate, there are vibrations produced, and corresponding to any vibration you can have wave packet, which is called phonon. So phonon is nothing but you can say that it is a particle very similar to photon ખાલી ફોટોન છે ઇલેક્ટ્રોમેગ્નેટિક વેવ માટેનો પાર્ટિકલ છે, ફોનોન છે એ વાઇબ્રેશનલ એટલે એને સાઉન્ડ એ કહેવાય. ફોનોન જે ફોન છે, ફોન એ ઇંગ્લિશ વર્ડ ગ્રીક વર્ડ છે. ફોન is Greek word which means sound. Phonon was the concept given by a Russian physicist Igor Tamm in 1932. Igor Tamm. And he said that if you don't consider vibrational energy, you will not be able to get thermal conductivity and electrical conductivity of any material accurately. And based on that, he gave concept of phonon. Phonon has its energy, which can be given as HF. Phonon છે એ vibrations છે, એની energy HF થી જ આપણને મળે. ઓકે, ફોનોન છે એની માટે તમે મોમેન્ટમ h cut k લખી શકો, just like photon. There are two types of phonons. One is acoustic phonon, other one is optical phonon. Actually phonon છે તો mode of vibration છે એટલે આને acoustic mode અને optical mode એ કહી શકાય. In case of acoustic phonon, the positive and negative ions vibrate together. So if this is how positive ions are arranged, you can see that negative ions are also falling on the same line. But if you are talking about optical phonon, in case of optical phonon it is not so. If this is how we have positive ions, you will see that negative ions will be vibrating in opposite manner like this. So this is optical phonon. So two types of phonon. What is phonon? It is quanta of vibration. Let me show you. These are the two modes. This is the momentum and energy. A phonon is collective excitation in periodic arrangement of atoms. જ્યારે atoms કે molecules vibrate થાય ત્યારે એની જે vibration ને corresponding wave packet મળે અથવા vibrational energy નો જે packet હોય એને phonon કહેવાય. Phonon can be produced in solid and liquid only. You cannot produce phonon in gas. Atoms vibrate about their mean position at finite temperature. These vibrations produce vibrational waves. Phonons are quanta of this vibration and travel with the speed of sound. Their wavelength is determined by crystal constant. જે અણુ અથવા પરમાણુની જે arrangement છે એની ઉપરથી phonon ની wavelength તમે નક્કી કરી શકો. And we cannot get phonons out of the solid. It exists only inside. They are non-radiative waves. Presence of phonon affect physical property like electrical and thermal conductivity. And there are two types of phonons: optical phonon and acoustic phonon. Take screenshot. Okay, so here is the summary. Two topics we intended to do today: effective mass and phonons. Two possible questions. So you may write down this 22.
Sorry,
question
50 marks
22.
ની પહેલી slide કરો ને.
Ha. This one. Slide.
Yes.
Okay.
Effective mass ની છે.
Okay. This one.
Sir, first page of your effective mass.
Okay. Let me stop recording first.